Yep. Just for organization purposes, this is two sides of a paper, no, one side, two sides. We're going to work on stuff from math 3, specifically Pascal's triangle today. If you don't remember it, it's totally fine, not a big deal. It's not really going to affect your knowledge here because this is all stats related. But I do have a spoiler. You can actually do calculations for the binomial theorem, which is what Pascal's triangle is, in your calculator, but we did not teach you that. Well, I didn't teach it to you because I didn't want to, but the other math teachers don't know that it exists. So, because it's stats, it's a stats thing, it's not their fault, they just wouldn't do it. But you definitely do need a calculator, so grab that. Okay, first thing I want to talk about is how horrible this problem would have been to do in chapter 5. Okay, so chapter 5 is your probability chapter, right? And you're like, well, Mr. Talbot, this one says probability, and that's true. It's just that I want you to think about how the tree diagram would look for something like this. So I had a student during chapter 5 was making their note card, and they said to me, they're looking through the test topics, and you guys remember the at least one situation, and at least one is the complement of nothing. So you find the probability of nothing and then 1 minus that. You guys remember that from chapter 5 was the last little bit we did. Okay, so then that student was like, okay, now what do I do for at least 2? What do I do for at least 3? What do I do for at least 4? Why are we just concentrating on at least 1? And I was like, because that's in the next chapter. So you could just close your brain on that, because that's a much more difficult question to answer than at least what. And I'm going to show you back here the start of it, what it would require. So you're this park ranger guy, right? Okay. And you walk up to a tree and it's infected or not infected, which I'm going to put infected complement. Does that make sense so far? And there's a 16% chance of being infected and an 84% chance of not being infected. Okay, and then the park ranger would walk to the next tree. This is tree 2. So second trial, infected, not infected, infected, not infected. Yeah. Okay, and then you would have to go out to 30 trees according to this problem here. So this problem says, okay, your trials are 30. So you'd have, this is trial 1, trial 2, trial 3, and then you would have to add up all of the branches where exactly 5 were infected. So this would be like 2, you see what I'm saying? Like you would go along the branches and you would only choose the branches that had exactly 5 infected, and then you would add all those probabilities together. It sounds horrible. That's why we don't really do it that way. Okay, but what we can do instead is try to make it fit the binomial model. And if we can make it fit the binomial model, we can calculate this probability in about 3 seconds instead of doing I don't even know how many branches that would be. It's a lot of 2 to the 30th. Like, anyway, okay, anyway, so. Okay, I want you guys to read this in your groups for 30 seconds and come up with 4, there's bullet points here. Try to come up with 4 things that you think might be requirements for a binomial distribution. Don't write them, just read and discuss. Kaylee, if you want to move, you can. Yeah, don't write it down because I want it to be perfect in your notebook. Just think and talk. I can hear Jackson. He's got one of the four. Good job. Yeah. They're really, really off topic. Okay, I'm going to give you the four. I want you to congratulate yourselves if you had any kind of thoughts in these four things. So the first thing I was hoping that you would notice was independence. Okay, and you might not have said the word independent, but you might have noticed the words no pattern in the infections. That means that just because like another tree is next to another tree doesn't mean that it's more likely to be infected or not, which is weird. I don't know how I feel about that as a context of a problem, but whatever. Okay, so this bit is important. Okay, the next one is it needs to be a success or failure type of situation. And what I mean by that is your only options are infected and infected complement, success or failure. Now, real quick, success in this chapter does not mean something good all the time. So a success could be an infected tree. I know it's a little weird, but you have to think of it mathematically, success, like kind of what the question's asking. Okay, and in this one, the context is infected or not infected. So you kind of really have just a success or failure. It's just two options. Okay, the next one is consistent probability. And that means that it's repeatedly 16% each time. So we're going to name that P equals 0.16. Lowercase p, we're going to use that through the whole thing. And the last one, I'm not sure if you thought about or not. I actually heard someone say something about it. Fixed number of trials. In this case, we're going to call it the number of trials n is 30. So you're going out, you're trying this 30 times. Okay, how many of those did you guys touch on? Okay. So now we're going to calculate the probability. And the reason I have pre-calc question mark there is because I asked Ms. Rice and Mr. Nat. Okay, so I know I'm recording and Mr. Nine, if he hears this, I love you. I'm sorry, but he the further in that he taught pre-calc, the more topics got left out. I know. So somewhere in the last 10 years, the probability chapter just left. I don't know what happened. It just didn't get taught anymore. Now in AP pre-calc, I asked both of them and they both do this binomial theorem with my expanding Pascal's triangle, binomial expansion, all those things we did in math 3. But they don't actually use this notation. So I think that the College Board is lying. But I checked your AP classrooms and there are questions that use this notation, so I think it's just, we don't say pre-calc, we're just gonna say AP. I don't know, whatever. But, okay, so can you guys imagine my tree? Pretend I made it out to 30 trials. You guys all understand this is the first trial, this is the second trial. Imagine I spent all day making a tree that went out to 30 trials. You can use Pascal's triangle to figure out how many of those would have exactly 5 infected. That's the whole point of Pascal's triangle. It tells you how many of each thing. Okay, so we don't need to get into that a whole lot because it's really the same for all of our problems, but our proper notation would be this. So the probability that X is exactly 5 trees. Okay, and then it looks like this. Now, if you had me for math 3, or Miss Rice for math 3, we gave you a resource page in your packet last year and the year before that had a bunch of different Pascal's triangle representations in it. And this was one of them that I told you to hold on to in your brain for stats. But really, this means 30 combination 5. You guys should remember 30 combination 5. This part is in your calculator. So this piece tells you how many of those branches would have exactly 5 infected trees if I went out to 30 trials. I don't need to do that or explain that anymore. It's the same every time. Okay, and then you put the probability of success, which means infected trees would be 5. And the probability of failure, so this is infected complement, would be 25. Okay, I need to pause on that, make sure you guys understand where all of those numbers came from. Okay, so this tells you, again, how many branches would have 5 infected trees. And then this is saying infected trees, there's 5 of them. Not infected trees, there's 25 of those. Okay, let's practice typing this in the calculator. Okay, so all calculators are different again. If you remember from like our RAND-INT stuff, the combination and permutation was in math probability. And in my calculator, I can fill in these little boxes. If you do not have the ability to fill in the little boxes, you might need to type the 31st and then do it. Oh, this is what I'm looking for. Does anybody have an older calculator that they need help with? Lexi, you're just going to type the 31st. Okay. Okay, so again, I really want you guys to understand what this did before I move on. So imagine the giant tree diagram. Can you guys imagine it? It's got 30 sets of branches, right? This calculation tells you how many of the branches would have exactly 5 eyes, and all the rest would be eye complements. So it just counted up 5 eyes, and that's how many there would be. And then this would be the multiplying down the branch, where 5 of them would be i's, and the other 25 would be not i's. Do you know what I mean by multiplying down the branch? Okay. Yeah, of the tree. So this is just taking your tree and making it nice and distinct in one little calculation. Okay, now we're gonna do the stats way. Unfortunately, I looked at AP Classroom last night. I assigned the ones for this chapter ahead of time because I'm organized. Look at me. And I looked and there's notation for both. So you need to know how to do both. But I have to tell you, you're going to prefer the stats way because it's just way easier. Okay, so notation here is the same. What's the probability that you have exactly 5 trees? Okay, and I want you to go in your calculator where normal CDF is, so second vars. I don't know if you've ever like scrolled through this menu. We've only used the ones at the top 3, but I'm a lazy human, so hit the up arrow. And notice all the stuff that's in this menu that we don't normally look at. Okay, look at the other stuff in there. Okay, I want you guys to go here. We're in binom PDF. So this is a binomial situation. Binom PDF is what we're looking at. And binom PDF will ask you for some information, just like normal CDF. The number of trials is 30. The probability is 0.16 each time. And the X value is 5 out of that 30. And you label this NPX. So 30 trials, 16% chance each time, 5 out of the 30 infected. Crap, did I round improperly? It's half point off for Miss Talbot. Okay, and then if you're asked to write a sentence, it's just a 3rd grade conclusion sentence. There's nothing to remember. You just write a conclusion. Okay. Now, this is what I would like you to do in your groups on your own. I would like you to write this. I would like you to do the recalc style right here. I would like you to do the stack style right here and verify both of your answers are the same. Definitely talk to each other. Yeah, same context. Mhm. All right, I have a weird problem already. Yeah, my calculator won't do the pre-calc style. Okay, but that's okay. We'll just do the stats part and then put it equals that for our pre-calc work. It will do the stats one though. It, I mean, you can set it up and show your work and then work backwards is what I'm gonna do. Okay, when you're ready, take a look at mine. Okay. Any questions about where I got numbers from? I know I picked too big of numbers, I guess, for the combination part. It'll do the exponent, just won't do the combination. Because the calculator's dumb. Well, not dumb, it's just not expecting to have to go that far down in Pascal's triangle, I think. But that's fine, because I just reverse engineered my answer with the binom PDF. Okay, now I'm gonna give you guys a chemistry test.
No.
It's silly, okay. So, do you guys have this down? Do you have it written down? Do you understand where my numbers came from? Everybody good with the numbers? Okay, okay, all right. So now we're gonna switch contexts for a bit, and then we're gonna go back to the park ranger, but I need to switch context for a hot minute. We're going back to the context, but I need to switch context for a moment. I'm gonna bring you a chemistry quiz that you need to share between two of you. Just read this one.
Oh, so. I don't think
Yeah, yeah, yeah. Oh, it's, Here's your chemistry. I'm sure you can grab it and do your thing. All right. Yeah, that's what we're doing. Yeah, I'm not saying, but.
That's why wait a second. Okay, but.
Oh, shit. I was gonna say 47. No, I'm gonna say. I feel like you're older. I'm probably not like that. What? I feel like or zero. I'm getting graduation. Okay, so what I want you guys to do is, once you get this bit set up in your notebook, I want you to read the chemistry test, well, just for fun. And I want you. I want you to decide, I want you to look back at the 4 requirements for a binomial distribution and decide whether or not your chemistry test fits a binomial distribution. So, do you remember the 4 requirements? Independent, success or failure? Okay, so I want you to look at the context of your chemistry quiz there. And we specifically made it, impossible, because we don't want you to know the questions. This is pure random guessing. So notice the bit of randomness that's involved here. Unless you know what a scatflight is, then definitely tell me. You made them up. I didn't make up anything, but did I? I think it is made up. Okay. The quiz itself doesn't matter. You're using it to help you decide if it's binomial or not. And I think no one's gonna be and then so when it's not broke, no
I think we can.
Can you guys please try to decide if your chemistry quiz is binomial? Okay, go back to the 4th thing. Is each one independent? Yes. Yep, okay. Yeah. Okay. Is it independent?
Yeah.
So does your answer for one question affect your answer for the next question? So it is independent. Okay, so underneath the first bullet point, put independent, check. And when I say does not depend, what I mean is all 5 options are still open to you on the next question, no matter how you answered question 1. So I'm talking mathematical independent, not common sense independent. I noticed some multiple choice questions are actually dependent. Cause like it does matter what you answered for the previous one. Okay. Next thing was success or failure.
Yeah.
Is this a success or failure situation? Yes, right or wrong? You get the question right or you get the question wrong? Success or failure? Check. Okay. Next one, consistent probability of success. Okay, that's true. And that's because, I forget who said it, Why are there so many answer choices? Well, it's because they have the same amount of answer choices each time. So 5 answer choices, right? What's the probability of success in each question? 1 out of 5, right? Okay, so put P equals 1/5 equals 0.2. Does that make sense to everybody? Because there's one correct answer. Actually, I don't know that there's correct answers on this one. But let's just pretend. Okay, what was the last one? Fixed number of childs? How many childs are there? 4. 4 questions. Okay, so then write fixed number of childs, check, n equals 4. Okay, so when you're guessing on a multiple choice quiz, it is a binomial situation. Interestingly enough, while you don't know any of the material, you could sit there with your calculator, figure out your probability of getting 1 correct or 2 correct or 3 correct, which is what we're going to do now. So set up these tables first, and then I will help you guys fill them in. Oh, cripes, I forgot something. Okay. So let's remind ourselves how to make a valid probability model. The outcomes are going to go on the top, the possible outcomes, and the probabilities of those are going to go on the bottom. And when I talk about outcomes here, I mean you get 0 questions correct, or you get 1 question correct, 2 questions correct, 3 questions correct, or 4 questions correct. That's all the possibilities in this particular situation. Okay, now what I want you to do is go back to Binom PDF. We're going to fill out the table. I'll get you started. So back to Binom PDF. Again, when I go to this menu, I'm lazy, so I scroll up instead of down. You can scroll down, whatever you want. But we have to change up our situation here because this is about trees, which is not what we're doing here. So the number of trials is 4 because you're doing 4 questions. The probability of getting a question correct is 0.2. And then the X value I'm looking for in this particular bit of the table is 0. So this will be the probability that I got nothing correct, which is probably high because I don't know any of the answers. 0.4096. So there's about a 41% chance that I'll get nothing right, which is not really shocking. Okay, now be smart. Scroll up, enter. Change that to a 1. Don't freak out about this being the same. It's just a quinky dink. So that means there's what, like an 82% chance that I'm gonna get 0 or 1 correct, which makes sense. Okay, scroll up. Enter. 2. Okay. Fill in the rest of the table. And what should these all add up to? 1, right? If we do it correct? Okay. Now we're going to create a cumulative probability model. So cumulative, again, if you remember, is adding them all up as you go. So the outcomes are the same. We're going to go slow because I want to make sure you understand what you're doing. So the first box is just the probability of getting 0 correct, which is 41%, which makes sense to me. It could be really hard to get any of them correct if I don't know any of the answers. Okay, now this box is the probability of getting less than or equal to 1 correct. So you add these two, which is kind of what I was saying earlier. So it's about an 82% chance that I get either 0 or 1. Are you guys following me? Okay. Now you're going to add the 3. Any questions from where my numbers came from? Are my numbers correct? Okay. Just, Okay, now what I want you guys to do is go back to the distribution menu in your calculator and go to binom CDF. Not PDF, CDF, the other one we haven't done yet, for Childs 0.22, which is this box right here. Okay, so now we need to do a definition. This table was PDF and not Adobe Acrobat PDF, Stats PDF. And this one is CDF. And let me tell you what those stand for so that it makes more sense and you're not just memorizing something stupid. So this top one is called binomial probability density function, which means that there's some kind of density curve. This one would be a histogram. Can you imagine a histogram built out of that table? Like with the probability on the side, like 0.4, 0.4, 0.1 through 0.15, you see it? Okay, and then this one, PDF, is binomial cumulative density function, which means that you're adding them all together. The thing that you need to know, it's really important, is this cumulative means less than or equal to. Meaning you're adding up everything below and equal to it, which is what we did here. So what I suggest you do is put the alligator symbol less than or equal to for CDF. Okay, so the rest of my lesson today is to teach you what to do for all the other inequality symbols, because we have 4 inequality symbols that we use in math. Less than or equal to, greater than or equal to, less than, and greater than. So the rest of the period, not the rest of the period, it's not going to take the whole time, but the rest of my lesson is just to make sure you know what to do for all 4 of the different crocodiles. Yes, they're crocodiles. They just have to be. And now we're going to go back to the trees. Okay, you guys sound ready? Okay, so we're gonna practice the PDF again. So first thing I'm gonna do is read this. It says exactly. That means equals. Exactly means equals, equals 8 trees. That means that I'm doing PDF. Okay, so we're back to the beginning of the lesson. We're gonna do it 2 ways. We're gonna do it with the combination. We're gonna do it with binom PDF. Okay, probability x equals 8. So I have 50 combination 8. Does that make sense so far? Okay. Infected, there's 8 of those. Not infected, there's 42 of those. Okay, can you guys try to type that in? We'll see if that works. Okay, and that's the other way you can do it, which I'm hoping will be the same answer. If not, I'm really special lady. It should be. Should I do it? I should probably make myself do it, huh? Ha, 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 redemption. Okay, any questions about the PDF business, the order of the things? Okay, so now let's work on the CDF. So on each of these problems, what I want to do is I want to translate the words into the crocodile. And then I want to do the proper CDF. Okay, so 8 or less. 8 or less, what is the crocodile for that? Less than or equal to. Okay, I gave you a softball down the middle for the first one. Less than or equal to is the way your calculator speaks. That is cumulative density function itself. Okay, so we're going to say probability x is less than or equal to 8. Binom CDF. And remember, CDF means it's adding up everything up to and including 8. And does it make sense to you that this number would be a lot bigger than your other number? So this one is just 8. And this one is 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. You got it? You with me? No? Okay. More than 8. What's the crocodile for that? Just plain greater than. Okay. And what I'm hoping to convince you of is that greater than is the complement of less than or equal to. Greater than is everything else. So you just do 1 minus this. Okay. Any questions about the first two? We have 2 more and then we're done. Less than. Oh, that's a really hard one to translate. I should have put fewer than. Lost opportunity. This is the crocodile for less than 8. And this is the notation for less than 8. Okay, however, what I want to convince you of is that because these are discrete, this is equal to that. Because you're not going to have decimals of trees that are infected. Okay, so we won't. It won't be binomial because think about it. It's success or failure. It's like you're not, it's yes or no questions basically. 0.4406. Okay, now what I would like to convince you of is that greater than or equal to is the complement of less than. It's everything else of this one. Mm-hmm. Is that all four crocodiles? I believe so. Okay, I have a joke for you. I would like to show you Pascat's triangle. That's what the combination thing is doing. So this is like three combinations. Zero, three combination one, three combination two, three combination three.
There. Second full.
You did the whole thing?
Oh, wait, actually.
What you do, man? Really? No, I don't know that they're real. I think they might be made up. I don't know that. The demonstrate test.
Are we gonna?
Do you guys know what a skylight is? Can they bring it for now? Chat GPT, what about for you? Oh, yeah. You bring that in? Oh, yeah.
Where do you use table V?
Oh, yeah. I don't even use the chat. Just give every morning and bring it to. No, I don't think there are any. I probably. I want to.